This is CPM Precalculus Chapter 1, number 149. So we're given f of x is equal to the cube root of x plus 2. So first we're asked to find f of negative 1 of x. Well, we know that means the inverse function, not anything else, right? Inverse function. Okay, so to find the inverse function, we start off by asking ourselves, how was f of x created? So f of x, remember, started as just y is equal to x. Then what happened? Well, we add 2, x plus 2, add 2, and then we finally take the cube root. Cube root of that cube root. Okay? And so this is now our function, right? So to get our inverse function, remember we do the opposite in the opposite order. So we start out with y is equal to x again. Then we do the opposite of the cube root. Well, the opposite of the cube root, remember that the cube root is simply x plus 2 to the power of 1/3, right? This is the cube root. And so the opposite of this, to cancel this one out, we're going to take it to the power of 3. So the opposite of the cube root is cubed, right? The power of 3. The opposite of adding 2 is going to be subtract 2. So here we're done, right? And so our inverse function is x cubed minus 2. Okay, part B, we're asked to sketch our function f of x and our inverse function f inverse function of x on the same set of axes. Okay, so what do each of these look like? Well, just really quickly, we know that this one looks like x to the power of 1/3 shifted up, right? Because we have plus 2, shifted up by 2 units. And this one looks like x cubed shifted down by 2 units, right? So let's go ahead and graph these. So first we have x plus 2 to the power of 1/3, and I'm going to put the power in parentheses, so it's not just to the power of 1 and then divided by 3. And then I have we have x cubed minus 2. Okay, so these are both functions. Let's graph them. So this one, okay, this looks like our first one, x plus 2 to the power of 1/3, and this one is x cubed minus 2. So let's graph these on the same axes, meaning on the same x and y axis. So here's our x-axis, our y-axis. So we know this one, oops, I said shifted up. Well, we know that means shifted when it's inside the parentheses. I totally messed up here, but I caught this. So we know when we add 2, we're going to shift to the left by 2 because it's inside the parentheses. Okay, outside the parentheses means we shift up and down. So this one is shifted down by 2. Okay, so let's look at this. So our first one, it looks like this. It's basically x to the 1/3 power shifted to the left by 2. So 1, 2, it's going to be like this, right? And x cubed minus 2 is shifted down by 2 and is just x cubed, right? Like this. Okay. So now we're done with that. So that's the sketch of, here is f of x here, and here's our inverse function of x. All right. So now we want to find the inverse function of f of 6. So let's do that. So remember, we start at the innermost parentheses. So we still have what's on the outside. What's f of 6? Well, our function f of x is the cube root of x plus 2, right? So it's the cube root of x. Well, x is 6. 6 plus 2. So that's equal to the inverse function. Let's simplify that. The cube root of 8. So what times itself 3 times equals 8? Well, 2 times 2 times 2 is 8. So that's equal to 8. Is equal to 2 inside. So now we have the inverse function with the input of 2. Our inverse function is defined right there. So we have wherever x is, we replace it with 2. So it's 2 cubed minus 2. 2 times 2 times 2 is 8. 8 minus 2 is 6. Okay? Alright, so that was this one. And now let's do f of the inverse function of 2. Okay, so again, we start with what's on the inside of the parentheses. Well, our inverse function is just x cubed minus 2. So wherever we see x, we replace it with 2. So it's going to be 2 cubed minus 2. Or 8 minus 2 is 6, right? F of 6, well, our function of f is over here, is just the cube root of 6 plus 2. That's the cube root of 8. And we know that's 2. So what do you notice? Well, when we wrap our function with, or when we wrap 6 with our function and the inverse function, our output is the same thing as our input, right? We wrap it with the function and the inverse function, they kind of cancel out and we're left with what's inside. Likewise here, we wrap it with the inverse function and then our function, they cancel out and we again are left with what's inside. So what do we notice? I notice that the inverse function and function wrap and unwrap each other, leaving the input left alone, right? Whatever we put as the input, it's now the output. Whatever's the input is now the output. It doesn't matter which order these are in because they cancel each other out. Okay, this ends CPM Precalculus Chapter 1, number 149.